Hello everyone, this is A.Krishna from third year mechanical studying in SRIT uh, with bearing roll number 244g5a0304. Today I'm going to present you about cutting speed, depth of cut and feed. These three are the general terms or regular terms we daily see when we are performing operation on a certain mission. Example like lathe mission, drilling mission, whatever you may take. When we are using certain tool, these three parameters comes under. Okay. First let's get introduced to the mission parameters. So before we get introduction, you see here uh, the workpiece rotating with speed n and the tool is removing the material with going in a horizontal direction, that's called feed, and the upper portion, the distance how much the metal is removed is called the depth of cut. Okay. Yeah. Introduction. Machining parameters are essential factors that influence the efficiency and quality of machining processes. Of course, cutting speed, depth of cut and feed are the primarily parameters. There are a lot of parameters, but these three are the primary one because these determine the tool life and surface finish. Understand these parameters helps optimize machining operations for the better productivity and quality. What is cutting speed? Cutting speed refers to the peripheral speed of the workpiece relative to the cutting tool. It is usually expressed in meters per minute or feet per minute. Of course, we generally use meters per minute. Proper cutting speed ensures efficient material removal and prolongs tool life. Factors affecting cutting speed. Material properties of both the workpiece and the tool influence the optimal cutting speed. Tool geometry and sharpness also play significant roles. Machine power and rigidity can limit the maximum achievable cutting speed. There is a picture. See, effect on tool life. That is, cutting speed affects the most, and next feed rate, and the least one is depth of cut. These three affect the tool life. Okay, that's the picture there. How to calculate cutting speed? Cutting speed V, or denoted with V, is calculated using the formula V is equal to pi into D into N. By 1000, where we all know D is the diameter and N is the RPM. Selecting the correct cutting speed involves considering the material and tool type. Manufacturers often provide recommended cutting speeds for the various materials and tools. Whenever we buy some machine or buy some tool, in the manual box they will automatically give the suggested speeds. Importance of cutting speed. Appropriate cutting speed reduces cutting forces and heat generation. It directly impacts tool wear and overall machining efficiency. Optimizing cutting speeds results in better surface finish and reduced machining time. What is depth of cut? Depth of cut is the thickness of the material removed in one pass of the cutting tool. When workpiece is revolving and when the tool is contacting with the workpiece while revolving, the how much material removed per one pass or one revolution, that's called the depth of cut. It is measured perpendicular to the surface being machined. Controlling the depth of cut helps prevent tool overload and damage. Factors influencing depth of cut. The strength and rigidity of the machine and tool affect maximum possible depth of cut. Material hardness influences how deep the cut can be safely made. The desired surface material removal rate also determine the depth of cut. Calculating and setting the depth of cut. This is also very important parameter. Depth of cut is typically set based on the tool's design and material considerations. For turning operations, it's often specified in millimeters or inches. Incremental increases in depth of cut can be used to optimize machining without overstressing the tool. Significance of the depth of cut. The significance of the depth of cut. A large depth of cut can increase the material removal rate but can cause excessive tool wear. Smaller depth of cut improves surface finish but may increase the machining time. Proper selection balances producing and tool life effectively. What is feed in machine? Yeah, we have seen the depth of cut and now we will see what is feed. Feed refers to the distance the tool advances in the workpiece during one revolution. When the workpiece is revolving like this, when the tool gets contact with it, how much the tool advances per one revolution, that's called the feed. Nothing, in simple terms, the distance of the tool traveled in 1 revolution. It is usually expressed in millimeters per revolution. Feed rate influences the amount of material removed per unit time. Yes, that's what the major thing. Depend on the feed, the material removal will occur. It is not too very important to cut the material with very high speed or with very low speed. There are certain speeds. Uh, for example, if you take thread cutting operation, if you give heavy feed, the pattern may be misalignment. The proper V shape, the proper threads are not produced. So feed is very important. Factors affecting feed rate: material hardness and ductility determine appropriate feed rates. Tool geometry and sharpness influence achievable feed without damaging the tool. The desired surface finish also impacts the selection of feed rate. Calculating feed rate. Feed rate can be calculated using the formula F. F is equal to F into N, where F is feed per revolution and N is RPM. We are calculating feed rate. Higher feed rates increase material removal but may reduce surface quality. When we are removing material at a speed or with faster rates, the neatness or finish surface we cannot get. Proper feed selection ensures efficient machinability with acceptable surface finish. Role of feed in machining quality. Adequate feed ensures smooth surface finish and dimensional accuracy. Excessive feed can cause tool deflection or breakage. Too little may feed also be result in longer machining times and inefficient operation. Very slow feed also consumes lot of time, which is a waste of time. Interrelation of cutting speeds, depth of cut. These parameters are interconnected and collectively influence machining outcomes. Increasing one parameter may require adjustment in others to prevent tool damage. Careful balancing ensures optimal performance and tool longevity. Optimization of machining parameters. Using of data charts helps select appropriate cutting speed, feed, and depth of cut. Modern CNC machines allow precise control and adjustment of these parameters. Continuous monitoring and adjust to improve machining efficiency and quality. Practical considerations in parameter selections. Like what should we consider while selecting these parameters? Always consider the machine capabilities. Okay, the machine capabilities and limitations when setting parameters. Material specific guidelines help prevent excessive tool wear or damage. Experimentation and experience guide the refinement of optimal cutting parameters. Common mistakes to avoid while selecting these three. Using excessive cutting speed or depth of cut can lead to tool failure. Of course, the tool is a very sensitive one. Of course, not sensitive because it removes the material, but operating is very sensitive. Ignoring material properties results in poor surface finish or tool wear. Not adjusting parameters for different materials and tools can compromise machine quality. Conclusion and summary. Cutting speed, depth of cut, feed are fundamental parameters in machining. Proper understanding and control of these factors optimize tool life, surface finish, and productivity. Continuous learning and adjustment are essential for efficient machining operations. I thank Mr. Dr. Piru Naik sir and all HODs who gave me this opportunity to present about this CAA-2. Thank you so much.